Well, hello, I'm Tom Barbalet, and I'm here to present on my project Noble Ape that some of you have been using for a bit of time currently. Next slide, please. So I wanted to kind of clue you in on the origins of Noble Ape and talk a little bit about some of the history initially and how I started developing Noble Ape. It's classed as an artificial life simulation. And there's a lot of ways that you get to artificial life, but I wanted to give some background to my early history. We'll talk a little bit about the fantasy games on the next few slides, but the technology that I developed prior to Noble Ape related to landscape visualization. This is planar landscapes, vector landscapes, quite detailed, water flows, plants, some kinds of animals. I had a UFO simulator that flew over the vector landscapes. The SchmuckQuest series of games, as I was writing these notes, I've actually found one of the 3.5-inch disc SchmuckQuest labels, which was relating to narrative, pretty well standard graphics adventure game, some text interface as well. I wrote antiviral software for a couple of years. You may wonder what antiviral software has to do with Noble Ape. Well, the heuristic analysis in particular used for finding various viruses at the time moved into the agar simulation. I wrote compilers. I've actually written a compiler professionally as well for Ericsson, but back in the day I wrote series of early polymorphic compilers and compilers for specific purposes. And these agar and petri dish simulations, which just tracked bacterial growth, these two are really linked. The antiviral software led me into, when I stopped writing antiviral software, into simulating agar and petri dish kind of bacterial growth. And as we'll see in the Noble Ape cognitive simulation, that led into information transfer. Anyway, next slide, please. So there's a lot of discussion currently about artificial life and where people get their ideas from in artificial life. I had this book, it was lent to me by a friend when I was about 8 in 1984. And the background to this was really about creating fantasy environments, rich fantasy environments that had detailed narrative, that were persistent and stable. You had obviously a character that went through. I was talking to Kit just before we started in terms of contemporary computer games, and a lot of them were inspired through these kind of books, and certainly it inspired me with regards to Noble Ape development. So also some early graphics in there as well. Next slide, please. So this is just an outline. You have various classes of characters, and this really led into the narrative, the strong narrative. This is in the Noble Ape simulation as well, as you see the various kinds of classes. And you're creating a dungeon environment that your character wanders through. This was done with like VIC-20 computers, BBC Micros, very early microcomputers, home computers at the time. Next slide, please. And the culture of this was that you got a section at the back of the book where you actually entered the program, here I think in BASIC, and you'll note along the side here there are stars and hashes and various other things, and that related to code for specific, well, they weren't really called platforms back then, but that was the general idea. And this is really where I got my early development from in terms of writing code books. I didn't have a home computer until the early 90s, so I used to go into the local university and program. That's some of the antiviral software. But certainly with regards to the early games and these kind of things, it was very much through writing out code and where particular kinds of microcomputers, or in the case of writing for the early Mac or for, DOS or these kind of things, I would put in similar notes. Unfortunately, my code books are probably long lost in Australia somewhere, so I thought this was a good example of the kind of discipline that went into that. Next slide, please. So this is the early Noble Ape simulation, and as I noted, I had a lot of bits and pieces of software that I'd developed prior to then, but Noble Ape really brought all those things together. We have a very simple landscape visualization here. You have water over land, various other components in the initial interface. I think maybe in a couple of slides' time we'll see more graphics associated with that. But I'd had all these ideas that had been percolating for probably 5 or 6 years, and I was in Malaysia at the time, and I was completely captivated by the ape populations, the orangutans and various monkeys that lived around my mother's house in Malaysia. And that really was the kind of focal point for developing Noble Ape. And when I got back to Australia, I was in university at the time. I was studying physics and philosophy. I got sick. I was sick for probably 4 or 5 months where I couldn't leave my dorm. And that was the period where I wrote the original manuals. And these were really the founding documents for the Noble Ape development, but outlined a lot of the broader philosophy, a lot of the background in terms of the kind of stuff that I've been developing prior, and what would really come together in Noble Ape. Next slide, please. So rather than being the Noble Ape simulation, you should really think of Noble Ape as a collection of simulations. This is another early graphic from the Noble Ape simulation showing a contour map. The original simulation, the landscape was created through Fourier transform, simple sine waves, which created a very simple landscape. And if you've seen the Apple WWDC 2003 presentation, basically that landscape algorithm was still in place with the stuff that Apple was using back then. However, I've developed a new landscape algorithm. I'll talk a little bit about that in a minute. There's also a weather simulation, and originally the weather simulation and the cognitive simulation were very heavily interlinked. I know you folk deal quite heavily with the cognitive simulation in terms of distribution and optimization, but my hope is in the future, because I'm looking to redo the weather simulation in the near future, that it could be more like the cognitive simulation, particularly to build up some of the SSE optimization for larger scale weather simulation. But we'll talk a little bit more about that in a few minutes. And of course, the biological simulation. So what you see here are just Noble Apes on the island, the early island. But underlying that was a rich biological simulation that had lots of plants and animals and various other things, and that's going to be expanded as well. Next slide, please. So the current Noble Ape landscape simulation comes from a development that I did around 2000. So Noble Ape was launched in 1996, and this was a development actually that I did when I lived in the Bay Area. And the idea here is that you have a planet. Underneath the planet, unfortunately, I used to have colour versions, but I only have the monochrome version is the only one that persists that I have in source code. So what you have here is a contour map with water over it, and then you have cloud cover going over that. And it simulated an entire planet. It had all the underlying Noble Ape biological simulation, but very rich environment. I guess a kind of dream for the future would be to return to the planet simulation in some regard. But the current simulation takes the landscape tiles from there and does a 2D binary division on random values. So it starts with very high, large values and then gets increasingly smaller to virtually tiny values. And then there is a 45-degree rotation every other iteration, so it doesn't look all voxely and square, basically. There's rounding over the entire landscape as well, which creates some of these rounding effects, basically. And in the future, really this is probably talking about the next couple of months, I'm going to be moving to a much larger landscape simulation. It's currently 256, one of these landscape tiles specifically. It'll be moving to 1024 relatively rapidly and possibly even larger. We'll get into more slides that talk more about that a little bit later. But as I said, both the landscape and the weather simulation came kind of circa 2000 from the Planet Noble Ape development. The early weather simulation was very similar to the early cognitive simulation. They were both two-dimensional, but neither of those technologies persist. Next slide, please. So, the weather simulation. My hope is in the future that maybe you guys might pick up aspects of the weather simulation as well, particularly as it becomes much larger, possibly even distributed. So I thought I'd give a few slides just describing what the weather simulation does and leave it with that. So the idea of the weather simulation is that you have an undulating landscape underneath and then almost you have a ceiling on top. And what you're doing here is you're tracking pressurized water vapor in the air, in the simulated air, as it moves over this landscape. And obviously when the pressure gets higher, you have cloud cover, and then if it gets even higher, you have rainfall. So it's really this moving simulation flow over the landscape that creates these weather effects. It's currently done at half the resolution of the landscape. So the landscape is 256, the weather is 128. And it's done that way primarily because of processor use. I guess you guys have probably seen it's about 10% of processor use currently for the weather simulation. And it was done that way because of just the weighting associated with that processing. In the future, this may be distributed. This may be something which is further optimized, possibly SSE optimized. So I think the future looks good for the weather. Anyway, so the weather simulation as it is currently is represented in two integer arrays combined. Next slide, please.
That's why we never really focused on the weather, because it didn't eat up a lot of the computation.
I think my hope is that if we can get some hybridization between the weather and a cognitive simulation with some underlying mathematics, then basically they can both be optimized together. But this is for the future. I'll talk about that in a couple of slides. So anyway, some background on the weather simulation, and this is possibly to be changed in the near future. But there are two arrays. There are two integer arrays, and the first array is used initially in population just to fill the half land value. And the second array is used to populate what I'm calling a slip coefficient. So if you imagine that you have the landscape, you have a kind of flat ceiling, and you have the weather undulating, the movement of the airflow could originally have been done with vector calculus. But instead of doing that, I used a simple slip differential, which you can see here, which is used as a kind of additive effect to affect the flow, basically. Second array is maintained and should be considered like a slip scalar, and the first array is initially 0. Next slide, please. So the first array is used really to calculate the kind of flow of pressure, and here's the math associated with that. We take the differential, then we take an inverse differential, so almost fighting against the slip. It's a competition between the slip and the existing pressure. And it's normalised here with the width and the area. There is still a normalisation factor, and I think the weather simulation is going to be rewritten in the near future to get the normalisation right. In fact, as I was going through the slides for this presentation, I found a couple of things that I'd like to change in the weather in the future. Currently, however, there's a fellow called Bob Mottram who's using the simulation in the UK. We'll talk more about him in a couple of slides. But what he's added to the weather currently was wind, where basically the pressure differential creates a wind characteristic which affects the vegetation, noble ape movements, things like that, and also basic tides. So my aim with the future weather simulator is not just that it will have this kind of heavy ceiling, fixed landscape, but the water as a kind of fluid will interact with the weather simulation and almost push the water up and down, create waves, create tides, particularly as you get much larger planetary simulations. There should be some very interesting effects with that. And I think that's coming in the future, but currently we have wind and basic tides that Bob Mottram implemented. But in the future, hopefully we'll have more interesting tides. Next slide, please. So I got slightly ahead of myself. It will be at the resolution of the landscape, which will be larger initially, but I think increasingly it will probably become a lot larger and probably slightly more complicated weather simulation as well. As I mentioned, based on the noble ape having size plus the wind, there'll be effects of wind chill. The noble apes will move to vegetation for shelter. And I'm interested in mapping other kinds of phenomena as well, other kinds of weather phenomena. When I started developing noble ape, there were a few folk, and I've had probably, I don't know, maybe a ping every other year from people that have an interest in weather simulation. And I think this is something which has been relatively secondary in the noble ape development to date. But I think if we can add interesting effects like snow and cyclones and other kind of weather-related phenomena, particularly for some of the stuff I'm going to be talking about later, I think there's going to be a lot of interesting stuff that comes out of it. So as I was saying, adding tides and water currents based on the weather is a new feature which will be coming very soon. Next slide, please. So I wanted to talk a little bit about the biological simulation, and that is based on quantum mechanics. And before you draw breath, it's the idea that the landscape is like a underlying wave function is the terminology. How many of you have a background in any knowledge of quantum mechanics? Okay, some. One class, okay. So you have this idea of the landscape, and the landscape as a three-dimensional form has properties, well, it's a planar form in 3 dimensions, has properties associated with surface area and differentials at every point in the landscape. So from those differentials, you can create secondary operators, which are basically things that you just sum together or subtract to create population densities. So in quantum mechanics, these are used for a wide variety of things that aren't biologically inspired. But here you have operators like surface area. So for example, you don't want a rock, exist. Well, you could have a rock on a cliff, but it's far more likely to exist on a flat piece of land. Far more likely for a tree to exist on a flat piece of land. You might have a small tree coming out of a cliff, but not a lot. You need water for various things, obviously fish and these kind of things like water. There's moving sunlight, which is now hooked into the weather simulation, and also total sunlight. And these are basically things which are applied on the landscape and now things from other aspects of the simulation that enable you to create equations like, for example, a specific plant may like flat area, water, total sunlight, and these kind of effects. You might have salt bush that likes a little salt. So you can create ideas of biological species that are, in fact, based on very simple underlying values like the land area and these kind of things. So that's the notion of biological simulation. And here what I've done with RGB values is take 3 plant varieties and just show their population densities, basically. So there's an underlying landscape. Ironically, I think blue here probably does actually represent water as well, low values. In fact, that's probably the high points of the land. The whiter values are probably more the water. But Bob Mottram has also added salt to this. And really, there are a number of operators that could be added to the biological simulation, but Bob picked salt in particular to allow for sea fish, seaweed, beaches, these kind of effects to be in the biological simulation. The reason that operators were used versus, for example, like having large arrays, which just did like growing plants and other methods, was that that was very processor intensive. If you think back to kind of 96, 97 era technology, we needed a method, or I needed a method to simulate the biology of the noble ape environment, which also now is scalable. So Bob Mottram added in an edible array, which just tracks the edible vegetation over the simulated space, and that's still quite processor intensive. It's on par with the weather simulation, but it's a lot easier. If you imagine that in very quantum mechanics terms, the biology only actually exists where the noble ape's interrogated. So rather than simulating the entire area for all this biology, it's better to just simulate the individual points. And these operators really drove that. Next slide, please. So this is the future of the biological simulation. Firstly, to add a lot more species, and here in inverted commas, these are just combinations of operators which give different real-world effects. The other thing that we want to do, and here I'm saying we because Bob Mottram and I are working on this together, is create fractal environments. So if you understand that the noble apes, their actual movement is at a far higher resolution than the resolution of the landscape, when they're actually wandering on the island or a part of a landscape, they need to have a sense that there is actual real bushes and real trees. So it's no longer the idea of population density and just saying there's a probability of some berry bushes being there. I'm actually looking at fractal mapping algorithms to translate what the biological simulation is saying down to actual simulation, noble ape simulation level vegetation. And this is proving some interesting effects initially. So here we have dark green trees, light green grass, purple for bushes, and you can see the kind of effects early on. But it'll probably be a lot more rich fractal environments in terms of actually mapping it down to real-world views into the simulation. Next slide, please. So, a little overview with the cognitive simulation. It was originally developed in 2 dimensions. It was originally very similar to the old weather simulation, has elements in the new weather simulation as well. This is actually the original noble ape cognitive simulation running on 2D at the fabled noble ape shed back probably, I don't know, 97, 98. Running on an old XT. Anyway, it's now done in 3 dimensions, 32 by 32 by 32 cells, and it's based on some of the early agar petri dish simulation that I did. Basically, the bacterial growth that you found in agar also represented a kind of information transfer. I wrote about this recently in a book called Nature Inspired Informatics, and if you're interested, I can circulate that chapter to you folk as well. Because that really gives the kind of full end-to-end with regards to the cognitive simulation and the derivation in particular from agar and petri dish simulation. So within this, I developed 2 mathematical ideas, the idea of desire and the idea of fear. And desire is a spatial delta, it phases out over space, and fear is very reactive, it evolves over time. And these 2 competing equations are in the cognitive simulation. And also they map back on real-world things. I mean, the idea of desire in terms of something, I might have the desire to take a sip of water in a period of time. The way in which it evolves in the cognitive simulation is very much based on long-term, and fear is very reactive. In the current version of the simulation, you can actually switch these on and off as well to get a real sense of what they're actually doing internally within the simulation. Next slide, please. So anyway, as I said, changes over time, which I call DIDT. The capital I is short for identity. It's not like the identity matrix. It was a terminology that I used for the kind of noble ape identity, the cognitive simulation, and changes over space, DI, DS, obviously space differential. It's similar to neural networks, but it's not a neural network, and really doing the writing in nature-inspired informatics kind of reinforced that, I think, to the academic community. Next slide, please. So in 2001, I tuned the cognitive simulation, and you may have seen these variables as you've played with the simulation. These variables were done purely manually and actually quite independently. So ironically, the awake state, there's no residual associated with the prior state. 171, 146 divided by 1024. These numbers were all hand-tuned, and they were hand-tuned over a long period of time based on various constraints. I write in Nature-Inspired Informatics about the methodology associated with tuning these kind of things, and it relates back to, are you familiar with predator-prey models? Where you've got like cats and or foxes and chickens, and they have a kind of interrelationship, calculus interrelationship. If you have complex biological simulations, you can also tune these variables. It's a skill which the mathematics is still not very well done in, and it's something where I think there could be, for the mathematicians and academics, there could be a lot of work done in that field. But certainly, really part of artificial life too, in terms of actually how you tune these simulation variables. But I wrote a version of the noble ape simulation in 1997 for some high school students, where you had basically the populations of plants and animals that you have in noble ape, and you had various sliders where you could tune them and look at what happened with the population densities over time. It's a very similar skill. You move up one thing and you see how it evolves, and oh, look, all the fish die. You move up another thing, oh, all the parrots take over and all the plants die. So you have all these sliders, and really that was the same method that I used for tuning the noble ape cognitive simulation. You'll notice something here. I did these two independently, and this is roughly half, well, exactly half. So what you have in phenomenal terms is no residual brain in the awake state, reacting purely on desire and fear, slightly more desire than fear. Similarly here, in terms of equal weighting, however, you have the background kind of residual sleeping brain element here. So this is the distinction between awake and asleep. There'll be more, we'll talk in a couple of slides about how this will actually move on. But this is the cognitive simulation as it stands today. Next slide, please. So in the future, the cognitive simulation is currently very underutilized. I mean, you guys use it, and a few other people have tinkered around with it, but it's not, it's not really a bleeding edge thing. Writing in Nature-Inspired Informatics was in part trying to introduce the academic community to the underlying ideas, but it's still underutilized, and it's underutilized in the simulation. My hope is in the future to get more stuff wired into it. We'll talk a bit about that in a couple of slides. But what I want to do with the simulation in the future is there was a kind of a feral cat population, the fierce felines, that were very competitive with the noble apes in the original simulation, and strong narrative associated with these two. And probably in 97, 98, I pulled the fierce felines out of the simulation because basically they preyed on the noble apes, and it wasn't particularly fun in terms of, interaction, tinkering if the noble apes died out so rapidly. But the idea of having another cognitive entity, another tunable cognitive entity in the simulation is something that I still have strong interest in. So the idea will be probably you'll have noble apes with probably an increased brain size. You'll have the fierce felines, which will probably inherit the noble ape brain size. And then there's a potential for things like predatorial birds or various other creatures to have slightly smaller cognitive simulations. And I think all these things will work out probably in the next couple of years. The other thing that's interesting, and I wrote about in Nature-Inspired Informatics, is this idea that you have an awake state and you have an asleep state. You have nothing in between. You've got the chance to tune around that. You've got the chance to create noble apes with different kinds of brain chemistry. But there's no kind of fading in and out. There's no notion of anger or the kind of brain chemistry that goes on through a variety of biological effects. And that's really something that I want to add in the future in terms of both time and chemical effects and how that changes the cognitive simulation. The other thing about the cognitive simulation is that simulators have the ability to throw it away. So A fellow who contributed a lot to the Noble Ape simulation maybe 2 or 3 years ago, Pedro Ferreira, who currently works at CERN, he actually removed the cognitive simulation and put in his own cognitive model. And that's really something which is open for Noble Ape in the future. Next slide, please. So, down to the nuts and bolts, the structure of the simulation. I'm not sure, if you guys are using the most recent Coco, then you probably already have seen the structure. It has changed in the past year. But there's an underlying Noble directory, the universe directory, which is basically the simulation, the GUI, which is all the visualization and the specific platform. There's also an iPad version as well, so kind of Coco Mac, Coco iPad. But when other simulators talk to me about maintaining so many versions, they think, it's just nuts having all these versions, and it does take a bit of time to maintain them. My interest, however, is just maximising the number of users of the simulation, and I think everyone has their own particular flavour with regards to platform. The idea of the platform code is it's just very, very thin, and obviously with the stuff with Apple, they've done some tuning, but really all the meat has to go on under the platform code, so the folks who are running it on whatever platform they choose can see the benefits. Next slide, please. Oh, sorry. There's also a command line version, which is the version that Bob Mottram develops with. And it's funny because I'm working with Bob in kind of semi-real time. He's based in the UK, I'm based in Las Vegas. But I'm using all these, and he's only using the command line version and still getting output from that. So it's interesting development having many different interfaces to it. Next slide, please. So the Noble directory was created probably 2 or 3 years ago, and that's because there are 2 projects here. There's Noble Ape on one side and Noble Warfare, and we'll talk about Noble Warfare in a couple of slides' time. But it has all the memory handling and the file handling, and it also has ApeScript. And I realised when I got to my hotel room last night that I've really not put in a lot of slides about ApeScript. But it's the potential for folks to come in and script the simulation and the directions that they want to take it. Pedro Ferreira, for example, for his own cognitive simulation, used ApeScript exclusively. It has access to the brain memory. It can do a wide variety of things. Next slide, please. So the universe directory tends to be the area that you guys seem to be most interested in. It has the land, biological, and the weather simulation, various Noble Ape movement reprogramming associated with that, the cognitive simulation, and also now the simulation core. Originally, the simulation core was kind of spread between the GUI and the universe directory, or whatever it was previously called. But I moved all the stuff down into the universe directory just so it was easily moved between the command line and the graphics. Next slide, please. So, as I said, the GUI directory has all the linking with the platform, mouse, keyboard, etc. And it also has the drawing. And the drawing in the Noble Ape simulation is hand-rolled to this day. The landscape graphics, the brain display, all this stuff is stuff that I've written, and it doesn't use OpenGL, it doesn't use any faster graphics technology. It's all basically just writing out bitmaps. And that's certainly something that folks at Apple have had things to say about in the past, but I still like it. I think in the future there's potential for an OpenGL interface, but as we'll get to in a few slides' time, a lot of this stuff will be rendered moot with future versions of Noble Ape simulation. But as it is currently, all the drawing is done internally in the GUI directory. And also then you have the platform directories, which are all very thin, Coco, Windows, command line, and the GTK for Linux. Next slide, please. So Noble Ape is a hobby for me, and I develop it after hours. It's just me most of the time. There are people who come in and contribute source code, but it's been 14 years, it's been a passion, but it's something that I do as a hobby. It's something I do occasionally over weekends. I've got other things that take up my time as well. But really the trick with developing it has been associated with long-term project planning. So, for example, the recent issue that we found in Coco with regards to the 4 windows moving down to the 2 windows, I had to work out how to kind of work out what I had to do in what order and these kind of things. And you find this also with new platforms. So moving from Classic to Carbon to Coco on the Mac, it's all about basically allocating time, working out how to organise these things, and then allocating your time accordingly. It's the notion that It's not going to happen instantly, but it will actually happen. In fact, the iPad development was a recent one where it happened a lot faster than I expected. So, I mean, sometimes you luck out, you get the faster, and sometimes it does take a lot longer. The original Carbon implementation, which is really the reason that I'm here, because the Carbon implementation was what Apple picked up early on, that took about 18 months. And that was 18 months of a pretty hard slog after getting home from work and working through the weekends in order to get that implemented. So obviously there's continuous bug fixing. I get bug reports pretty frequently from various users. There's about between 500 and 800 kind of what I would call advanced users of Noble Ape Simulation. The downloads are still pretty good, and I've done a release recently. I'm going to be doing a new release very soon. But there seem to be a lot of people that are using it, and I do get bugs through that. As I mentioned, the ongoing platform maintenance is just a constant thing. Apple's constantly tweaking things and making APIs obsolete. And also, there's a real distinction between doing this kind of project and doing what you would do in a company or something like that. There's a constant dialogue with the users. I've utilised podcast, audio, some YouTube, not as much as I'd like. But just ways, and also Facebook, a lot of the social networks elements have been very productive in terms of getting people communicating about their use of Noble Ape and also getting a sense of features that folks want in the future. And this is really what you guys do as well. You get occasional amazing contributions of source code. And really, in terms of developing open source, I think that's one of the best things about it. So next slide, please. So, in the past month, I've had some amazing contributions, and really fortuitous that I'm coming here and giving these talks, because I would have talked a lot more about ApeScript and the cognitive simulation. But there's next slide, please. There's been a fellow in the UK called Bob Mottram, who's a roboticist. He's known both in the professional robotics community and also the hobbyist robotics community. He's done a lot associated with robotic vision and visualization. Just a phenomenally smart fellow, and just a real privilege to have him working on the project. Noble Ape is considered an artificial life simulation within the artificial life community. Bob Mottram is known by some people. There's a fellow called Steve Grand, who now lives in Arizona but was based in the UK, who wrote a game called Creatures, and Bob Mottram has had a long-standing connection with him. There's a kind of Venn between the artificial life community and the robotics community. Obviously, there's hard artificial life, which is actually robotics, but even with the soft artificial life, and Bob has just contributed a phenomenal amount of source in the past month. Next slide, please. So, the first thing, and I actually picked all the names for Bob, was that we started creating real-world names for the Noble Apes. And this is a means of not necessarily just embodying what the Noble Apes are, but just a means of easy debugging. You can't say the Noble Ape at, X257, Y, what have you, or some other thing. Why not give the Noble Ape a unique name? So if you're actually debugging associated with a specific ape, then it has a name. And this feeds into stuff we'll talk about in a minute with the narrative engine. He also added grooming and parasites. And this is the idea that the Noble Apes are actually apes. They have fur, they have parasites that live on them. And the grooming rituals that apes do actually yields a lot of additional effects. So the parasites are generated randomly, but they grow in numbers, and they're also transmitted as the Noble Apes move against each other. And the grooming creates a system of honour. So Bob has created this idea that there are various kind of honour categories in the Noble Apes, and they get honour both by grooming, which is a very kind of passive interaction, and also by physically fighting. And so there are physical disputes between males of different families, and this notion of families is linked in through the double-barreled surname and the underlying new genetics that Bob put in there. But anyway, more on this. Next slide, please. So the Noble Apes now have selections for particular appearance. We'll talk about that with regards to the genetics. They avoid, in terms of their preferences, apes that have similar names. The naming conventions will go through the genetics. The Noble Apes now also have gestation periods. So the female apes get pregnant, they carry their young, and they have parenting interaction. So, for example, after the baby Noble Ape is born, the mother carries the child, and when the child gets to a particular age, the child follows the mother. So they have this kind of bonding component that Bob has added. Next slide, please. When I started developing Noble Ape, there are many classes of artificial life simulations, and my interest wasn't specifically with regards to genetics. It wasn't about genetic algorithms or these kind of things. I was far more interested in mapping kind of cognitive simulations, social structures, that kind of stuff. What Bob has added is a far richer noble ape genome. And here are just some of the things: rate of growth, status preference, the pigmentation on the fur, then their pigmentation preference, the skill of grooming, aggression, their speed, their staggering, hill climb, the energy from vegetables, fruits and meats, and also the latent energy use. And this is a kind of competing genome. You will not have a super ape that does well in all these things. There are certain characteristics which are negative, positive, and this is an interplay for long-term simulation. Next slide, please. The big change, and this is a change which was requested by a number of external users and also game developers, was the idea of the Noble Ape web server. And what that is basically you have the Noble Ape simulation running on a web server that has an interface currently with Bob's implementation with regards to graphics. So all aspects of the simulation that you would normally get through the real-time application, you can now get through the web server. This is a kind of BBC-style weather map because he's based in the UK. The other thing that he added, which I thought was very cute, is Twitter reporting. So, for example, these are the examples of the double-barreled names. So Carver Davis Howard is in discussion. He's having some kind of conversation. Eliza Helen Hill Manson is the most honourable female. And the hashtag is #NobleApe. And for me, that was quite interesting. I mean, this is really embodying them in something other than just a standard simulation and giving an output. But the idea of the web server was something that had been requested by others, and Bob's really put that all together through the command line interface. Next slide, please.
So the simulation runs inside a web browser then?
No, it runs on a server. It's a Debian installation, okay. And then it transmits out. And the reason for the server was... I'm not sure if you're familiar with OpenSim or the Second Life client or these kind of things, but the idea is that if the Noble Ape simulation is running on a server somewhere, it doesn't take responsibility for the graphics. It can farm the graphics out to the Second Life client or some other environment, which means that the simulation is moved into being as rich as possible in terms of all the stuff that I've talked about, weather simulation, biological simulation, plants, animals, apes wandering around, and it's the responsibility of the client to do all the rendering.
And for the client, when you're displaying it, what do you use for the display? Is it like Flash?
This is to be decided. This is the future slide indicating that this is the direction that we're moving in. But yeah, I think there's opportunity, particularly for the Second Life client, and certainly I've had communications with the OpenSim guys who actually develop Second Life servers. OpenSim is the Second Life server open source, basically. So wide potential in terms of interfacing with Second Life. Similarly, there's the potential to actually run the simulation through a web browser and have a detailed interface, so as you were saying, Flash, what have you. This is, of course, to be developed. There is an open API that was developed in the artificial life community, which is currently going under the name Biota Eve. Oh, and there's a pile of Biota CDs for you to take as well. And the idea there is a kind of XML phenotype description of the noble ape or other artificial life entities, and this will also be used for the landscape and various biological prodding and backwards and forwards. So there's a potential through an open API to create a web browser interface. And the thing that I've been asked about since I lived here 10 years ago, was the idea of the Noble Ape simulation being additive game content. So that you have a game running and you want a world map, you want a simulated biology, you want something that your game content can interact with. And I think the web server offers that in terms of an open API and the ability for game developers basically to say, okay, we want a sphere so big, weather simulation, biological simulation, we want these kind of plants and animals, create it. And I think that's really there. Next slide, please. Another thing that Bob Mottram is working on currently is this idea that the noble apes can form a social graph. So this is really the idea that the noble ape exists as an entity in the simulation, but it also exists as a kind of broader historical figure potentially for the future generations of noble ape. And this is really turning, I guess, noble ape into something that's just more of interest for perhaps the social sciences, but it creates a lot of really interesting effects. So from the previous slides, Bob Mottram added a lot of new features, but what he's interested in tracking through this is long-lasting friendships, disputes, pair bondings, and basically making the social behaviour a lot more sophisticated. We'll talk a bit about the narrative engine in a minute. But this is the idea that the noble ape exists with a family, friendship group, perhaps enemies group, but also that is a thing that exists in time too. It evolves over time, but as the noble ape passes away, there's a potential for like a historical figure aspect, that there's basically like a narrative and mythos that goes through this. So you get jealousy, tribalism that emerges from grooming and squabbling, and you also get goal-oriented actions, and the movement back through this is still very early days, but similarly move towards friends, away from enemies, seeking out specific mates. The eye is there rendering. But yeah, it's going to be like Facebook. I'm not sure of the kind of graphical representation, but currently Bob is writing the underlying structure for that, and it's probably being developed as I'm talking to you currently. So I think probably within the next week or so, I'll have a beta of that back in the source code. Next slide, please. From my end, the things that interest me in the near term is building on this idea of the narrative engine. And Noble Warfare, which has been in development since about 2005, but links into the web server, and also Objective Ape Script. Next slide, please. So the narrative engine is this idea that rather than just a graphical entity, the noble apes exist in a simulation where things happen to them. And what we've done in the artificial life community to date is created these very rich environments with these entities that kind of move through the environments. But if you're looking at the screen and if you kind of understand that dot that's moving around the screen is an ape, then you've got a sense of that. But there's actually a narrative in terms of the ape's interaction with other apes, their environment, and these kind of things, which is completely lost in the running of the simulation. And certainly for the social sciences and also for a wide variety of users, this idea that the entities are moving through the simulation and create a narrative is something which is lost. And what interests me through the stuff that Bob has done and also some of my thinking moving towards that is this idea that you can map back these interactions in a kind of English language form which displays a lot of the complexity and also allows for debugging, and external observers can look at this narrative associated with this entity and actually get a sense that the simulation is a very rich environment, and more so than just providing graphics or game interaction. But it's really a different way of looking at artificial life simulating. Next slide, please. So as I mentioned, Noble Warfare, since 2005, just as I was leaving the UK actually. When I was in the UK, I was captivated a lot by the history and the fact that the place we rented looked out over an old battlefield, and there was a Bronze Age fellow buried in a bog nearby, and you get a real sense of history in the UK. And in particular, the effects that warfare has had on history and the loss of people, loss of genetic lines. There seems to be nothing done in the social sciences associated with this. So that was my background in terms of developing Noble Warfare as an adjunct to the Noble Ape simulation. But there also aren't a lot of real-time tactical engines in terms of game engines. And what has happened over time is that the artificial life community, a lot of the stuff that's developed within the community is borrowed in the game community, like Spore with Will Wright or Flow or these kind of games that are picked up, or all of the kind of SimCity products have all had links to the artificial life community. And this idea of Noble Warfare is really kind of running in tangent to the Noble Ape simulation, but it's the idea that a lot of the technology that's developed in Noble Ape is also applicable to these kind of things, and develop historical engines for various periods and appeal to a different set of users. Next slide, please. So I haven't really talked much about ApeScript. I had brought up in the browser behind what ApeScript looks like. I'm not sure in terms of your general use whether you have any need for ApeScript or any interest in ApeScript, but it is there, and my interest in the near future is actually to create a more object-oriented version of ApeScript. Pedro Ferreira used ApeScript very heavily. He created a checklist of maybe a dozen features that he wanted implemented, but there seem to be multiple productive uses for ApeScript as well. It's very, very small, very tightly constrained in terms of stability, these kind of things. It's based in the idea of a single time cycle. So what you have in ApeScript is really a single time cycle snapshot from the Noble Ape, which you can then program specifically. But I'm interested in translating it into a more formal, object-oriented format. There's always been talk about either using Lua or Python. Breve, which is another artificial life simulation, uses Python. Lua is very heavily used in the game development community. There's potential for that. I like ApeScript currently. You can get interactions with the simulation very easily, and certainly a lot of Bob Mottram's debugging was through the ApeScript interface. So it's useful for people that want to come in and access parts of the simulation, not necessarily through the source code, but through other methods. Next slide, please. So developing artificial life simulations, people come to you and say, well, why isn't it a game? Why don't you just make a game? And I think after 14 years of doing this, there's a simple idea, and that's that basically artificial life simulations almost exist like a novel. Whereas contemporary games are very much, and they really do, I've been a member of the International Game Developers Association for a decade. Contemporary computer games are developed like movies. They have movie-like budgets. The way that they develop from end to end is very much like a movie. And artificial life simulations are very much more like even probably self-published or maybe even blogs, who knows. But some kind of time-evolving thing which is very different from commercial game development. Now what interests me here is the movement that you see between novels and movies. Is the idea that basically most of what Hollywood produces now is based on novels or based on writing or comic books or these kind of things. And I think the artificial life community and Noble Ape, in terms of the history, in terms of the richness in the environment, really lends itself to that kind of relationship. But I think that's probably the distinction that I've found, certainly developing Noble Ape as an artificial life simulation and really only kind of putting my toe in the game development field sporadically. Next slide, please. So I think this talk has basically come to an end. I wanted to thank you all for your efforts and your development with Noble Ape, I think probably for the past 5 years. My first real experience of doing this externally, and I know none of you were at WWDC 2003, but it was the first demonstration that Nathan Slingerland and Sanjay Patel did of the simulation at 2003. In 2003, I was based in the UK at the time. I've not really had any interaction with people in terms of actually coming and meeting people who use Noble Ape. Occasionally people have come through Las Vegas and met me. The simulation looks very different than it did in 2003, and it's a good line in the sand basically to go back to that presentation and get a sense of what was going on back then. But I think there's a lot of new stuff to come, and I'd certainly like to thank you all for your efforts with regards to working with Noble Ape and your contributions back. So thank you.
So the iPad app that you referred to, is that, are you trying to generate revenue off of that? Or is
No.
it a free app?
No, it's a free app. The way that Apple has used Noble Ape seems to be in many parts. One of those parts is to do with actually developing applications for third parties, like an easy skinning. So, for example, I met a developer who used to work with the AppleWorks Kairos products, and he said they used to use it as an example for like skinning, basically, at where you start. So the iPad, I like the interface. It's about, for example, if you have the narrative engine, you select an ape and it actually tells you the story of the ape, or you select the ape and it gives you the ape script, which you can then interact with. I think it's a different kind of interface. I think it's a different kind of user base. I'm not interested in... if I did Noble Ape to make revenue, I would be very bitter and twisted and probably not be here giving you... It has to be a hobby. Otherwise, it doesn't evolve, basically. So my interest with the iPad app was firstly, how easy is it to take an existing Cocoa application, move it to the iPad, but then you have a new interface. You have a new group of users and you have a new way of interaction, particularly with regards to the touch. So still relatively early days. I mean, it's just basically a Noble Ape simulation as you see it in two windows, but on the iPad. But my aim in the future as well is to also change the aesthetic slightly. I think there's an aesthetic interface with the iPad too. So it's really just experimenting with the iPad as a new interface more than anything.
Is that code? Are you going to open source that?
It's on. It's you can yeah.
Okay.
So if you go to, I can't remember which directory it's in now. I think it's in the Cocoa directory. It's part of the simulation now. It's open source, and yeah, it all builds together. It's just basically it's exactly the same as a regular Cocoa build, except it's a new interface for the the redrawing that they're using. But anyway, it's all there. It's all open source, all part of the source. So if you have interest in,
I have an ulterior interest. We can
okay, very good. I'll turn the microphones off when. Okay. But no, so for me it was just fun, and I think I've always wanted to run it on an iPhone, and now with the new iPhone 4, the resolution's good. So, but then again, it's a completely different interface, and certainly early on developing Noble Ape. So, if you look at the old Carbon version, it's not on the more recent Cocoa. When you move the mouse over, the mouse actually changes as the window that you're interacting with, showing you that either you're moving through or these kind of things. So, I've always been really interested in it, like the interface aspect too, to kind of change the interface associated with different platforms and the interaction. I think there's another slide actually. So, okay, I'm giving a talk at SRI tomorrow. It's in Menlo Park at 7. I'm going to talk a lot more about the artificial life community and how all this stuff fits together. A lot less mathematics than I gave you folk today. Similar parts of the talk, but also an extended part talking about the artificial life community and the kind of legacy history, Noble Ape's connection with that. So that'll be at SRI. Are there any questions or any more questions?
I have one. So when you first started it, did you think that it was going to grow this big?
Big is a relative term. When I started Noble Ape, I've been developing software, and I was 19 when Noble Ape started. I wrote antiviral software when I was about 14, 15. That's the first check I got from writing software. My sense with it was that there was a critical need at that point to bring all these things together. I was in correspondence with a fellow called Douglas Rushkoff. I'm not sure if any of you have heard of Douglas Rushkoff. He's an author. He was an academic at NYU. He's done a variety of things. When I launched Noble Ape, I wanted to launch it with kind of a maximum impact at the time. So initially I had astrophysicists and various people who all kind of contributed ideas initially. It's kind of ebbed and flowed. The WWDC 2003 was really amazing to me because that was literally like a presentation on Noble Ape with a group of engineers presenting to a conference that was more expensive than I could attend, So it was kind of, there have been various points of impact. We talked a little bit about Steve Wozniak before. I mean, his people, I met him through Noble Ape. He had a kind of background interest in Noble Ape and his people knew about it. So there have been points where I've met people where I've thought, that's amazing that they're... But I think the way I think about this is a lifetime project. This isn't something I'm going to put down tomorrow. This is something where people can contribute and people come on board. Bob Mottram's come on board. I've had a couple of other developers who've come on board for long periods of time. But I'd like to see it utilised in a wide variety of areas that's not currently utilised. So it's kind of ebbs and flows. But it keeps me off the streets. It's been a good project. And I think the things that interest me now are how other people use it. Because, as I said, there's a lot of time that I spend just making sure that it runs on Cocoa. This Windows bug, oh no, I've got to write around this. So there's a lot of almost kind of parental maintenance that I have to do, basically. But it's really getting people like Bob Mottram involved who have like this idea and this idea and this idea and this idea, and then I'm fixing bugs for him and developing additional stuff. And so it's very dynamic, and I think it keeps me like mentally active. It keeps me like interested in a variety of areas. So it's been good in that way. No, this is an after hours. No, this is strictly after hours. I've always maintained it as an after hours project, primarily because I didn't want any external. When I lived here 99, 2001, 18 months here, and I was working with a lot of startups, and I was pitched very heavily that they wanted to move Noble Ape in various directions and take this. It wouldn't have continued to this day if it was my day job. In the past 10 years, I've had 7 day jobs. I've had 5 companies close. I've had an international move and 1 section close. The technology industry, as I've seen it, has been very brutal. And Noble Ape has always been like this unpermeable layer, basically, that I've maintained to make sure that I still have, like, for example, compiler writing. I mean, I wrote a compiler for Ericsson, which is the professional point that I did that. But I've always had an interest in that kind of stuff. So it's been able to kind of keep me interested in a wide variety of technologies, but maintained after hours. So yeah, in no way my day job.
So 2 questions. I know Tiger, this was part of the OS as an underperformance application. Is it still a part of the actual?
So I was hoping to meet with people at Apple. I'm meeting with Dr. Ernie at Apple tomorrow. My understanding is they still release it as part of the CHUD toolkit, so it's still on every Mac.
Buried in there. So,
You need to, a few drop-down menus and then you select. I'd like to see it used in different areas at Apple. You guys have been very lucky. I'm onto my 4th generation of Apple engineers now. Nathan Slingerland and Sanjay Patel left Apple 2005, and there have been a progressive number of engineers that have worked on it, and I find it now impossible to track the engineers at Apple who are working on it. Yeah, so good. I'm glad this is a mutual thing. And what I've done through that is I still maintain contact with Nathan and Sanjay. Nathan's back in the Bay Area, Sanjay I think is in Seattle. I've tracked the engineers who've used it since then. It's almost, for example, the Intel version that came out in 2005. I didn't even know that was out until 3 months after it was released. So
that was actually that was like one of the very first projects that Apple asked us to do.
Right.
They said that it was like a app that all the developers looked at some point.
Yeah.
And it was written with Ultima, so they said port it.
So that was about the time that Nathan and Sanjay, I think Nathan and Sanjay left probably a few months after WWDC 2005. So that's what got me in contact with Ernie, because I said, hey, it's great that you guys are doing this, but I'd really like to know about it being done, and I'd really like to kind of have a sense. And the license it was under previously, it's now under the MIT open source license. The license it was under previously was called the Ravenbrook license, and that required any commercial use that they get in contact with me and inform me of the contact. But unfortunately, the OSI board, the board that covers open source licenses, didn't like that license anymore. So now it's under MIT, which is basically free for all. But I would kind of like to know, because when I'm asked what it's used for, and I say I don't really know, it kind of implies that I do know, but I'm not going to tell people, and that's always difficult, particularly when you talk about open source. So I don't really know what it's used for currently. I'm going to meet with Ernie tomorrow. Hopefully he'll tell me more. But my sense is it's still used. I'd like to see the way it was used. There was a period of time, and this is the AppleWorks fellow, there was a period of time where it was used for like graphics optimization as well, and just the aspects of the real-time component were used. I'd like to see that used again. I'm not really sure what they're doing currently. There's one engineer who I maintain with, Brian Follis, who's over there. He's the only name that I maintain. Mike Smith left. I mean, there are various people who've kind of ebbed and flowed through the Apple, and really, well, Dr. Ernie is the only one who's left formally. Brian, I think, is constantly kind of on and again, off again in terms of his studies, but Dr. Ernie's tracked it since 2005 at least. So I'll get the information dumped from him tomorrow, hopefully, about the new crop of engineers that are using it. But I'd like to keep it relevant for them. It's been an amazing experience. I mean, the background to this is, the way Wozniak's people got in contact with me was I used to go into Apple anyway. There's a fellow there called George Warner, who I work with. Yeah. And he invited me in, I can't remember. But anyway, he was my first contact point at Apple. I went in. There was what you see in the simulation currently is associated with the planar. There was originally a first-person perspective planar landscape view that was in the simulation. He got me to display that at Apple, I want to say 98. So I've had a kind of constant group of people at Apple, but formally 2003, and that's when it was included with the Chud toolkit. And that's Nathan and Sanjay primarily.
Well, in your discussions tomorrow with Apple, I mean, we would be thrilled if we could get, like you can tell them there's a Grand Central Dispatch version that we're working on, and if they wanted to update it to that would
Okay.
be great and everything. Because I believe that the version that's in there is a little bit stale.
It's quite stale, and I think particularly with the stuff that happened, the 4 Windows to 2 Windows, that's got to be updated. There's got to be a Cocoa. I think it's still the old Carbon. The old Carbon one won't run on the new, so something's gone wrong.
Yeah.
Either they've updated to the new one, which I sent to them. I sent them the new one. So they've had the 2 Windows at the same time that you got the 2 Windows. But yeah, I've lost track of what's going on at Apple, basically, so I need to reconnect, and I'll do that tomorrow.
Okay. Yeah. I haven't looked at the latest one, but I know I've always kind of dug around and like, okay, it's still there.
The Carbon version won't run on the latest operating system because of the bug that I submitted. So I'm pretty sure they're using the Cocoa, but even the Cocoa one has interesting effects for their particular optimizations. So who knows? I'll find out tomorrow. Okay. I'll let you know.
So I guess as far as the rest of this afternoon. I thought maybe you could maybe sit with Brian for a few minutes.
Certainly.
And then maybe we could all go to lunch.
Terrific.